Example, if we want to calculate integral from -1 to 1 over x squared dx, and find the antiderivative by switching to negative exponent. So then antiderivative will become negative x to -1, negative 1. So we're going to get -1 over x from -1 to 1. Substituting the upper bound, we're going to get -1 over 1 minus -1. So we're going to get -1 minus 1, because minus 1 gives us both. So we're going to get answer is -2. So if I want to summarize, integral from -1 to 1 over x squared dx equals to -2. Look ahead. If you look at the graph, 1 over x squared, it's going to look something like that. We're looking for an interval from -1 to 1, then this integral represents that shaded area. So that integral equals to the area of that shaded region. Because on the interval from -1 to 1, function is positive, and so on. So definitely, area cannot be equal to -2. So what's the problem? The problem is we are using the fundamental theorem of calculus here. And the problem with using the fundamental theorem of calculus here, because if you look for interval from -1 to 1, we have discontinuity at 0. And actually that is infinite discontinuity here. So that's where a problem arises, because we have like infinite jump. So integral from -1 to 1 over x squared dx is not equal to -2. So we have to take special attention to such type of intervals. So if we have a finite interval, and on that finite interval we have discontinuity, and we have infinity and discontinuity, we have to pay special attention to such integrals, and such integrals are going to be called improper integrals. So with me, give that as a definition. Integral from a to b f of x dx is called improper integral. If actually there are two possibilities either. First, there exists C such that C is between A and B, and limit of f of x next approaching C equals to plus or minus infinity. Or second possibility is the interval of integration is going to look like a from plus infinity or negative infinity to a or negative infinity to positive infinity. Okay. So those are two types of improper integrals. So let's concentrate on the first type firstly, and then we'll concentrate on the second, and let's figure out ways how we're going to be able to do the calculations. So let's look at our integral which we just did a second ago a little bit more carefully. So we want to find what is this integral equal to. So what we do is we look at our interval from -1 to 1, and we know we have discontinuity at 0, and that discontinuity is infinite discontinuity. So what we're going to be doing is we're going to break our integral from -1 to 1, 1 over x squared dx into two integrals, one from -1 to 0, 1 over x squared dx, plus integral 0 to 1, 1 over x squared dx. Then we're going to calculate each of these integrals separately, and then hopefully be able to do the calculations. So let's look firstly at the first integral. From -1 to 0, 1 over x squared dx. So what we're going to be doing is we have integral from -1 to 0, and then we have discontinuity here. So instead of calculating the integral from -1 to 0 immediately, what we'll do is we'll pick a point on the side of the interval a little bit to the left from 0, then on interval from -1 to h. We're not going to have any troubles calculating. And that will be our approximation to the integral. And what we'll do with our approximation, we take that h closer and closer towards 0. And it's going to be approaching 0 from left. So then we're going to say our original integral, which was integral from -1 to 0, 1 over x dx squared, is going to be equal to that limit which we just set up. So now let's calculate for that limit integral. It's a regular integral, the derivative which we already did -1 over x. We're doing from -1 to h, so it's going to be limit as h approaching 0 minus. So we're going to now upper bound, we're going to get -1 over h. Substituting the lower bound, we're going to get +1. So we're going to get a situation where -1 over 0 minus that's what h approaching to, +1. -1 over 0 minus is going to be positive number, and if because we divided by 0, it's going to be huge infinity, infinity +1, so it's going to be +infinity. So what we got is that integral from -1 to 0, 1 over x squared dx equals to +infinity. Similarly, we can do calculations. We can calculate integral from 0 to 1, 1 over x squared dx. What we'll do is we'll set up a limit as h approaching 0 from right now, h to 1, 1 over x squared dx, and we're going to permit the calculations, and at the end we're going to get +infinity. So answer integral from -1 to 1, 1 over x squared dx equals to integral from -1 to 0, 1 over x squared dx plus integral 0 to 1, 1 over x squared dx. So we're going to get the first equals +infinity, the second equals +infinity, so total is +infinity. So we're going to say integral from -1 to 1, 1 over x squared dx is divergent. Equals to +infinity. Divergent means the value of integral is not equal to finite number. So that's going to be answer to this question. Generally, if we have integral from a to b f of x dx, and limit of f of x when x approached a from right to ±infinity, then we're going to set integral from a to b f of x dx is going to be equal to limit as h approaching a from right, integral from h to b f of x dx. Similarly, we'll do evaluate integral from a to b if we have discontinuity. So usually, if we have discontinuity in the middle, we want to break it into sum of two integrals like we did before, and then we'll do evaluate it according to what we just wrote. So let me basically try to write down an example. Example, integral 1 to 2 1 over x minus 2 squared dx. So we look at the interval from 1 to 2, and we have discontinuity at 2. So we're going to rewrite this integral as. We're not going to plug in 2 immediately. We're going to take some h a little bit to the left from 2. So h eventually will be approaching 2 from left. X minus 2 squared dx. So on limit as h approaching 2 from left, the derivative will be negative 1 over x minus 2. We're doing it from 1 to h. So we're going to get limit as h approaching 2 from left. Negative, so substitute in h, we're going to get negative h minus 2 plus divided by 1 minus 2. Substituting 2 minus, we're going to get negative minus 1, 2 minus h, 2 from the left minus h going to be 0, but it's going to be 0 negative. So final answer is going to be minus will be positive, and will be positive infinity. So we're going to get positive infinity at the end. So integral 1 to 2 dx divided by x minus 2 squared equals 2 plus